Buenas tardes todos. Welcome everyone. How's everyone feeling? Great. So I'm the first lightning talk, so I'll try to get the energy up again. So today we'll talk about software supply chain management with Kritis and Kritis. Who here has heard of the project Kritis? Raise of hands. Okay, great. What about Kritis? Sweet, awesome. So for those of you who know what the projects are, it will be a quick review. And for those of you who don't, we'll talk more about it. Don't worry, you'll know all about it at the end of this 10-minute quick overview. I'm Aysylu Greenberg. I'm the eng lead on Kritis and Kritis projects. And I'm online on Twitter talking about Kritis and Kritis if you want to follow. So where exactly does Kritis and Kritis fit in the software supply chain? So we have our engineer who builds code and commits it to the code base, and then she wants to build and deploy it. And so she will do this using the CI/CD pipelines that we've been learning about all day today. There's a lot of different choices to be able to do secure build, and then do automated testing, scanning for vulnerabilities, doing different types of analysis, for instance, license analysis on the code base, and then deploy checks before deploying to production. Okay, and so all the different types of metadata that are generated by the CI/CD pipelines can actually be stored in Kritis. So information like vulnerabilities and build information, source information, and so on. So Kritis is a centralized metadata knowledge base, and all the different CI/CD vendors just need to know how to speak the Kritis format and to be able to store it in the Kritis-backed storage system. And now Kritis, it will be used for deploy time policy verification. So it's an admission controller that basically will check policies. So for instance, severity of vulnerabilities or location of image, does it come from a trusted location? And then if everything passes the checks, then it will be deployed to production. Otherwise, the image will be rejected from entering production, and then there will be some clarification for why. And so now Kritis itself doesn't store any information about vulnerabilities, none of that. It actually talks to Kritis to retrieve that metadata information. So now we can create rich policies based on the custom set of things that you care about at deploy time. So this is the overall how Kritis and Kritis, where they come in the software supply chain and how they interact with CI/CD pipelines. And Kritis and Kritis are not new projects. They've been around. There's actually Google internal implementations of them that are available as proprietary products. And so now let's talk about Kritis a little bit in more detail. So I'll be referring to it as Artifact Metadata API. So let's unpack that a bit. So Artifact refers to images, binaries, packages. Metadata describes build, deployment, vulnerability, licenses, any of the type of metadata you might care about in your artifacts. And then API is storing and retrieving metadata about those artifacts. Okay? So now there's a couple of points of terminology that will be useful to understand what Kritis does and how it does that. So nodes are high-level descriptions of types of metadata. For instance, common vulnerabilities and exposures, known as CVEs in the industry, will be stored as a vulnerability node. And then occurrences are instances of nodes in a specific artifact. So for instance, a presence of a vulnerability in an image will be stored as a vulnerability occurrence. Now, resource URLs are unique identifiers for artifacts in occurrences, and so that's how you're able to tell, given this image, what is its build information and its vulnerability information, so on, and be able to link across all the different metadata that you have stored in Kritis and be able to reason about it. And so you'll have different ways to refer to it, like Debian packages and Docker images and generic files will have a way to describe them in a resource URL. Now we have kind-specific schemas, which are strict schemas, which allow us to, first of all, evolve our schemas and by adding new metadata types as we find needs, and also allows us to describe in a way that is vendor agnostic. So across different vendors, all the necessary information to describe build vulnerabilities is described in the corresponding schema. So for instance, we have deployment node, which describes an artifact that was deployed in some runtime. And so then resource URI will describe the resource that was deployed in a deployment node. And then deployment occurrence will have information like who deployed it, user's email, deploy time, maybe undeployed time, and so on. So Graphias is an open artifact metadata standard with contributions already from the industry. It's developed out in the open source. It's used to audit and govern your software supply chain. It's a knowledge base for hybrid cloud solutions. So if you have on-premises and cloud clusters, it's meant to support both. And it's an API with pluggable storage backends. I didn't go into examples of this, but you'll see in a moment how it doesn't really matter what storage backs Graphias. We have implementations against Postgres and Spanner and so on, and it just works. It's a universal metadata API. So what's Kritis? It's a deploy time policy verifier. So instead of talking about all the different features it has, let's run through an example, and then you'll see exactly how it works. So we want to deploy our e-commerce website. So the admission flow looks like this. We'll do kube control, apply site YAML, which describes our e-commerce site. And then so we'll send this command into the Kubernetes cluster, which has Kritis installed inside it using the helm install command. And so now the admission request comes in with a pod spec describing it, and it will be captured by webhook, which will review this admission request against a set of policies that we have. So imagine for QA and for prod namespaces, we have image security policies that we define in the CRD. If you don't know what CRDs are, we'll take a brief look at what they are, and you'll hear a lot more about them at KubeCon this week. So now, image security validator will be used to actually enforce those policies. And we'll fetch metadata for the vulnerability. So image security policy describes what vulnerabilities we are willing to tolerate on any given image that we're about to deploy. And so we'll fetch metadata from Graphias about vulnerabilities. So now, oh no, but with vulnerability scan hasn't finished, and so Graphias doesn't have any information about vulnerability we can fetch, and so at that point we will reject this pod and we'll reject the request, because we want to make sure that every single image that comes in, if image security policy is defined, actually has verified vulnerability scan has run. So now, vulnerability scanning is finished, and we found this vulnerability. Okay, so now Graphias is able to retrieve that and return that to Kritis, and the pod is denied because now we have some vulnerability. So now we investigated. Vulnerability analysis is a very hard problem, and we find out that it actually doesn't affect our image, so we can just whitelist it. Okay, fine. So then we whitelisted, and then the pod is admitted. Great. So now we succeeded. So now it's time to scale up your website. Now that you have one pod, let's scale it up to 4, and we'll do this with the kube control scale command. And as we brought up 2 pods now, and as the 3rd and 4th pod are coming up, vulnerability analysis that runs separately, maybe you pay a vendor to do it, or you do it yourself in a separate process, finds a new vulnerability. And so what does this mean? If we find a new vulnerability and now it violates the existing image security process, does that mean we can no longer scale up? That would disrupt our website, that would disrupt our customer experience, right? So to prevent this, what we have is Kritis attestations that come in. So taking a step back, when we first deployed the first pod, what happens is Kritis has an attester inside it that we actually, cluster admin specifies using attestation authority CRD, that any admitted image will also have an attestation written. So then we'll store attestation for the admitted image via Graphias. And then when a request to scale comes in, even if we find a new vulnerability, but we admitted this image, then we'll fetch attestations for the admitted image and then allow it to scale up. So now we're good. And now to make sure that we actually are discovering new vulnerabilities, so if Heartbleed bug is discovered, right? We don't want to just keep running our e-commerce website and never find out about it. So there is a background cron that runs and looks at all the running pods and then adds labels and annotations to it so the cluster admin can verify that these running pods are no longer satisfying image security policy. Great, so a couple points of terminology. We use custom resource definitions for storing policies as Kubernetes objects. It's an extension of open source Kubernetes API. And we use validating admission webhook, which is HTTP callbacks that receive admission requests, and then they either accept or reject to enforce custom admission policies, which is a pretty neat way of integrating into Kubernetes classes so that once you install Kritis, it just works. So now this is what image security policy, for instance, looks like, where we give it a name. The kind is image security policy. The name is name something like my image security policy, ISP. And now we can whitelist images, and we can say we will tolerate no more severe than medium severity of vulnerabilities found in the image, and then whitelist some vulnerabilities. That's just an example, and it could be very expressive. So Kritis was developed first and foremost open source, and it was built with the community, with the industry contributions. It plugs into Kubernetes admission controller. It ensures the vulnerability scanning is run if we actually enforce image security policies before deployment. And it tests images and verifies them before deployment and applies consistent deploy policy across Kubernetes environments. So a very exciting thing that is happening right now in the Graphias and Kritis world is the launch of 0.1.0 release that I've been working on. We're hoping to release it this quarter. So there's 3 goals for this release. One of them is to enable users to start experimenting with Graphias and Kritis on their laptops, desktops, and so on. We are moving towards hybrid cloud support, and we would like to gather community feedback from all of you once you try it out to help us prioritize what features are most needed in the industry, what features are most relevant and most helpful for you to be productive. The scope is to have standalone Kritis on Kubernetes with standalone Graphias server talking to each other. And the 2 kind of user journeys you can think about, what can you do with it? So you should be able to allow deployment of a container to a Kubernetes cluster that passes all the checks, and then block deployment of an unadmitted container to the cluster and actually see it fail when something is wrong with it. The features that are being added, just a quick overview, home chart for Graphias and a published image, and standalone Graphias server with Postgres storage backend is up and running and functional, and then basic support for Go client library. We have not forgotten about many of you who are using other languages. It's just that for this specific release, we'll focus on one language. That was the most requested language from the community. And then for those of you who use Python, Ruby, Java, and so on, let's continue working and talking with each other so we can prioritize this accordingly. And now in Kritis, we're adding generic attestation policies so that cluster admin can actually say, OK, this image is fine. Don't worry about it, running any checks. I trust this. I have manually verified it. So from now on, admit all the images that I've verified. And then also you could say, don't admit any of the images I haven't verified. So generic attestation policy basically allows you to do that. And now default admin's fallback policy is we want to make sure that it's well-defined. What if you don't specify any policies? And we want to make sure that Kritis is configurable for all of your different needs. So if you'd like to learn more and follow along, the 2 projects are on GitHub. Under Graphias organization, Graphias and Kritis. There's 2 Google groups if you would like to start using Graphias and Kritis, Graphias-users and Kritis-users. And then if you'd like to be contributing, there's the Graphias dev group. And we're also on Twitter, on Graphias.io. So now that I've concluded the talk, I'll conclude it with a question. How many of you are now interested in trying it out and or contributing to Graphias and Kritis? Show me a hand. Great, that's a lot more than I expected. That's awesome. Looking forward to your contributions and hearing from you. Thank you.
Hello. How are you guys doing? So my name is Erin Ericson. I work for Salesforce. I am on the product side, but I've spent most of my career as a software developer. And I've had a lot of experience fighting bad tests and having to deal with that kind of reality. So as I've thought about this and how it would help this kind of overall ecosystem of things that we have in the Continuous Delivery Foundation, my thought is, what if we did something interesting? So today we're going to talk about something I like to call a declarative quality engine that I'm naming CQO, which stands for Chief Quality Officer. So there's that. We might figure out a better name. I literally just named this today, so if you have a better idea, please talk to me. So the idea here, though, is we talk about continuous delivery. We talk about continuous integration. We don't really talk about continuous quality much, which to me is this idea that in a ubiquitous way, we ought to always have this kind of shift to the left working for us, so we always know that we're not just continuous delivering, but we're actually delivering software that we're proud of. So, the other way I like to put it is, CD is no good if you're always delivering crap, if you're always delivering, defects. And we think we're doing really well because we have a great test pyramid and all sorts of, things that we do to make sure CI is doing what we expect it to do. But it doesn't always work out because we have test pyramids of different shapes, sizes, and all sorts of other kinds of characteristics. We also know that not all tests need to be run at integration time. Not all tests can be run prior to when you check in. So there's different tests that need to run at different pipeline stages. There are budget limits. So, here at Salesforce, we have a rather large code base with about 1 million tests. It is not viable financially to run each test that we have for every single pull request that we get in our code base. So therefore, there are budgetary limits. We could easily spend, $5 billion a year running tests. That would pretty much eat our entire profit margin, so we probably shouldn't do that. So, any kind of system like this that uses a declarative engine has to say, well, what is our budget, and how do we stay within that limit? Obviously, we know the earlier you catch a bug, the cheaper it is to resolve. And so generally what you want to do is kind of solve it, understand whether you have a defect as soon as you possibly can. We also know that different substrates are optimal for different kinds of workloads. There's different kinds of ways that you can configure for different kinds of workloads. And being able to manage those trade-offs is something an engine like this ought to be able to do. We also know that not all tests are the same quality. Who here has ever seen a test that didn't have an assert? Okay, good. I want to see more hands. So, some of you are probably going, oh, I've never seen that before. How many of you have ever worked in an organization that said, thou shalt have code coverage to a certain percentage, and then saw some really bad tests happen as a result of that? Yeah, everybody in this room. And if you haven't, you're lying. I have stories I can tell you. Not at Salesforce. All our tests are perfect. but there's, I've been doing this for a while, and I've seen places that I have some more stories. But there's probably low quality tests that you could probably quarantine and just not run, or run less often, right? We also know that quality isn't just your unit tests. Okay, who here has a perfect unit test pyramid? Yeah, nobody has a perfect unit test pyramid. That doesn't really exist. I mean, we all aspire to it, right? We all aspire to have massive number of unit tests that run very, very quickly, and then just a small number of end-to-end tests that take a long time. But the reality is we have complex software, particularly as we go to more and more sophisticated organizations with code bases that are both brand new and 20 years old and 30 years old. And you're going to have all sorts of different kinds of tests that run in all sorts of different kinds of time frames. And so being able to kind of choose which ones run at which time is actually a really interesting problem. So what would a CQO engine look like, or a declarative quality engine? You would start with kind of a set of tests. So you have your set of unit tests, your set of performance tests, security tests, chaos tests, all sorts of different things you can run. You also have a set of constraints, right? You have a set of policies. You have a budget. A budget is a constraint, just like any other constraint. You have different kinds of environments that you have to run on and so forth. You have targets. So you might want to say, at a certain level of pass rate, at a certain stage, I consider that to be okay. You might allow for a certain amount of non-determinism in certain kinds of tests. In fact, it's generally seen as a good thing because sometimes you can model non-determinism in your tests that you expect. You also might just say, I have business outcome expectations. These are different kinds of tests that I want to say I got this much lift, and you might want to say what those targets are. So those are your inputs. Moreover, we want to run the right tests at the right time. There's all sorts of different kinds of tests if you look at this in a more kind of holistic way, where smoke tests I want to run early. I want to run certain kinds of security tests very, very quickly. Before somebody checks in, I want to know if somebody's putting in a secret into my repository and be able to just reject that even before I do a pull request. Okay, I want to be able to do smoke testing before I start putting it in lots of different environments. I want to make sure it works in at least the most basic ones as quickly as possible. There's certain kinds of tests that are more expensive, your end-to-end, your security, and so forth. I'm going to wait till the end until it passes other test suites that I have. Most of us know this, and we configure our CI/CD pipelines to do these things, which means every one of us in this room is doing something that a machine could do and make choices for us independent, but we're doing it ourselves. We don't have to. Okay, at the end, after deployment, there's even tests like, is it actually achieving the outcome I want? Is it getting the conversion I want? I might want to do other kinds of testing actually in production, and so we can actually manage that as well. But we do want to be conscious of the fact that obviously the ones to the left are cheaper, the ones to the right are more expensive, and that should become part of any kind of engine that's making decisions for us. So what would be the components of something like this? Okay. You would have something called a test prioritizer. What does that do? A test prioritizer says, based on the change you're making, based on your pull request, you will probably want to run these tests, and maybe not these tests over here. That becomes one of the levers that we can use to manage our testing budget and also manage down the amount of time it takes to get feedback that's useful to somebody. We may want to be able to say which tests are better or not. Okay, not all tests are of equal value just on its face. So there are high-quality tests that actually assert things, that actually run through the right parts of the code base, that run quickly. And there's low-quality tests. Okay, we ought to be able to rank those and choose them based on their rank. We ought to be able to have an engine, which is kind of like a controller that can inject the right sets of tests into the right phases of the CD pipeline, according to whatever kind of quality outcomes that we're looking to get. We need something to manage our test environments. We need an API first design. I think that's pretty obvious to most people in here. But we also need things to be plug-in driven so that we can compose these different kinds of workflows actually in real time. Okay, and actually be able to make decisions and run them in different ways as the system gets smarter. So how would we build something like this? And again, this is an early conversation. Unlike the last talk, this is something that we have parts of it, but we're looking for help in the community to decide, one, is this a good idea to do? And I hope we talk about that later. But two, how would we go about actually making this real? So there's components that go into a system like this, the ranker, the prioritizer. Talking before, the CI systems actually produce a set of useful things and a set of useful data that I call, or that we call CI nouns, or this is the set of test results. Is there a canonical way that we can talk about what test results are in a way that a system like this can reason about them? Right? That could be really interesting. So we'd start with these components that are independently useful outside of a system that orchestrates this stuff using machine learning to figure out then what are the ways that we map these tests to any kind of constraints that we might have so we can kind of meet the broader goal of actually managing to a budget or actually trying to have a system that puts the right tests in the right place over time and gets smarter about that. Okay, so that'd be kind of more of a phase 2 thing that we'd like to make happen eventually. So what are our outcomes? What do we get by doing all this kind of stuff? What I want to get out of the business of doing is deciding which tests run in what phase of the pipeline. I think a system can be smarter than I will be about what kinds of decisions I would make in that place. I want a system that's smart enough to make the trade-offs and manage the trade-offs with regard to which tests run where. Okay, I don't know that as humans we're always smart about those. In fact, as humans, we are very loss averse, and so we'll tend to run more tests than we need most of the time. So how do we have something that kind of more scientifically manages those trade-offs? And then, over time, as the system gets smarter, it can figure out what tests can go further to the left, what tests run faster. Help me actually manage my test base in a smarter way. A system like this ought to be able to tell you what tests are bad and give you advice about how you might refactor that stuff. So a lot of really kind of interesting outcomes that could come from this. So in the spirit of a lightning talk, my question, and again, we don't have to do it here on the stage, but let's talk today. Find me after the talk, find me, I'll be around. Is this something that's useful? Is this something that you would be interested in working with us on? We actually have something that does test prioritization inside of Salesforce. We intend to open source that and contribute that. But if there's other pieces of that ecosystem that you think would be useful or that we should kind of take into this as we start to make this more public, I'd be very interested in hearing from everybody or anybody that's also interested here today. All right? Thank you.
All right, good evening, folks. My name is Balaji Siva. I'm part of the OpsMX team. We are a startup based in San Francisco Bay Area. Today I want to talk about operator for Spinnaker. Before I get started, how many people are using Spinnaker in production? All right, not many actually. How many are interested in trying Spinnaker? Quite a lot. Okay, excellent. So I think so this may be a useful talk for you, because as you start adopting Spinnaker or trying out Spinnaker, we think that the operator model will help you get started quickly. So I want to cut to the screens. So most people using Spinnaker, they're using something called an installation tool called Halyard. Halyard is a tool that is available as part of the open source Spinnaker, and they use it to manage the Spinnaker services. Many organizations are using one single Spinnaker deployment to deploy to multiple groups. The Spinnaker obviously is a great multi-cloud deployment tool, so you're able to deploy to multiple clusters or multiple environments without having to deploy a Spinnaker per service, per region, for example. So that is something very much possible. It scales really well. But also there have been use cases where people have asked to deploy Spinnaker for a single group of developers or a team or project or et cetera. So you have a multiple instance of Spinnaker running. Spinnaker itself is a fairly 10 microservice application, as you have seen in the morning presentation. So in order for you to maintain that, it could be challenging, and that's something we think that this tool can help. I mean, from an architecture perspective, you can see there are 10 different microservices. You typically have to have database for both the pipeline configuration, which is usually a Minio or Amazon S3, for example. And also you need another database for maintaining the runtime information, like what the what pipelines got executed, et cetera, because you want to make sure that when a Spinnaker comes back up, you want to have all the information available. So this is usually how the application looks like. So the Halyard is the current model of deployment of Spinnaker, installation and upgrade, etc. I think but you have to. It's still not, I guess, seamless as many people want. One of the common things I hear from smaller teams is that Spinnaker is a little heavy for my use case, right? I mean, you're used to using scripts, for example, and this seems like a heavy approach for deploying a few applications. So that's why the operator is an interesting use case, interesting opportunity here. How many people are familiar with the operator concept in Kubernetes? Okay, a few people. So essentially, operator is something that was introduced recently, maybe a couple of years now at this point. It allows you to manage the lifecycle of Kubernetes application. In this case, the Kubernetes application itself is the Spinnaker itself. So now you're managing the Spinnaker as an application, and you have to want to worry about the day one and day two activities. Day one could be installation, day two could be upgrade, scaling, et cetera, So operator makes it very, very simple to do that. There's an industry effort around this topic. There are multiple phases in which you can build an operator. Operator is as an SDK. So for example, it doesn't have to be for Kubernetes, obviously. You can take any of your Kubernetes, for Spinnaker, for example, you can take any of your Spinnaker Kubernetes application and create an operator for it. Essentially, you're taking the operational aspects and putting it as part of the, to maintain all of this in an easy fashion. So you have phase 1, phase 2, phase 3, phase 4, phase 5. So essentially, you can look at it. Think of this as if you're having a stateful applications and you want to maintain the upgrade and lifecycle management, you can do that as part of the operator. The available operators and the publicly available operators are on the website called operatorhub.io. This is so you can see a lot of operators already there. And so you can take existing available operator and be able to deploy to your Kubernetes cluster. If you want to build a custom operator for your own internal application, you can do that. And that's the benefit you get with this thing. So in this case, we have an operator for Spinnaker that we have already available for you. So in this, you can go here and you'll be able to install this operator to get up and running with the Spinnaker very quickly. Our goal here is, in this case, it's just a level 1. Right now, it's basic installation, which is basically, still uses Halyard and uses Minio. It's maintaining the state of that. And within Halyard, we have made sure that you're able to do other services and maintain the state of all the other services also. So you can try that. This is obviously version 1. We want you to try it and give us a feedback. Our goal is to make sure that we have all the things available as part of the next version of the operator. So if you want more information about this particular operator and how you can use it, there's a blog that we wrote. It's on the OpsMX website. It's a Spinnaker operator guide. It also has a video that you can watch, which shows you how to install the operator. I'm not going to go through it because you can watch it later. For more information, definitely reach out to me, and I'm going to give you some URLs here that you can actually reach out as well. So operatorhub.io is where you go download the operator. And you also go to our blog to make sure that you understand what it is and how to install the operator and watch the video. If you have any questions or feedback, like I said, this is a V1 version. We will be doing more. Happy to get feedback and send us an email at hello@opsmx.com. Thank you.
Hey, everyone. My name is Kay Williams, and I work for Microsoft. I am in the office of the CTO for Azure, and I wanted to take a minute to talk with you today about software supply chain security and some of the thinking we've been doing at Microsoft. And my reason for this is that it's an industry problem, and I'd love to work with some of you folks on the same issue. Okay, so let's talk about software supply chain. What do we mean by that? So when I say it, I'm thinking about the entire supply chain, all the way from a component developer, someone that creates maybe a Python library or maybe a Linux kernel as a component, but smaller pieces of software. And they provide that to distributors. So that might be someone that provides a package repository. Excuse me, whether that be RPM or Debian or NuGet, et cetera. And then application developers consume that and create applications, and those get onto end customer systems. And so what we're looking for is a solution for security all the way along that pipeline, where at each step the actor can describe what it is they're providing, and the recipient can validate that and apply policies for what they're willing to consume. We've done a bit of work, again, this is really inside of Microsoft. Oh, I should mention, so I work in Azure, and I work with teams across Azure and then really across all of Microsoft on Linux and open source. And so this is a project that I've been working on. And as we've been out and been speaking with teams, what we've defined is that we would like to, our ideal flow is something like the above, where external artifacts come in at the top left, and those might be source code from source code repositories, artifacts from, or binaries from package repositories, or operating system repos, container registries. It could even be loose files and binaries. And ideally, those would all come through a kind of ingestion process. And during ingestion, things that would be taken care of would be governing some things by policy. So what things do we allow in based on the license, and especially in the case of open source, the license on those items, on those artifacts. What things do we allow in based on some security policies that we can set? Where did they come from? Who built them? How are they built? Et cetera. We also want to be sure that we're inventorying artifacts that we bring in for oversight so that we know what's being used where in case there are large security issues. We want to be able to clone for resiliency in case something from an external site, if that site goes down or becomes compromised. Then we're also interested in validating these things, validating artifacts for reliability even before we bring them into the developer system. Then once all artifacts have gone through some sort of ingestion process, they'd follow through the regular, through developers to developer builds, stable builds, and then the release process. So that's where we want to be. Here's where we are today. So the red arrows indicate all the places where external artifacts come into the system. And you know, this is and they can come in, you know, based on the team. Some teams are more sophisticated, some not as much. The more sophisticated teams will be trying to go through an ingestion process like this. Some of the less sophisticated teams, you know, we'll see artifacts coming in at all points in the chain, and unfortunately, even some coming in at the production stage, which is very concerning to us. One of the things that we find is that this ingestion section that I talked about, where we want so many things to happen, some of our teams are doing those things today. They're happening manually. We don't have good, strong processes around that. And that's something where we really want to beef up for ourselves, but we also know that many Microsoft customers and just people in the industry have similar concerns. So what do we need? We need some sort of security framework, and I know that there are some teams and some groups working on this, and the Graphius team is a team that I'm starting to do some, Microsoft and Google are starting to get together and talk about this. But the goal for the security framework is that software can move securely through the supply chain, and we can have signing and policy and validation at each step along the way. One project that we've looked at is called In Toto, and for that project they have the concept of signed metadata that describes the artifact, including the license and the build steps. They also have a way of describing policy for identifying what's expected and allowed into a system. And they also have a method for inspecting metadata to verify that artifacts meet policy. Another thing that we're very interested in is reproducible builds. And the reason that that's interesting in considering software supply chain is so that we can validate the integrity of build environments. It is possible to compromise build environments, compromise compilers even, so that they output vulnerable artifact or compromised artifacts, and it's very difficult to even know that that's happened. And the way to get around that is to have multiple independent systems building artifacts and then cross-checking those. Supply chain security, I've been talking about this as something that we've been looking at inside of Microsoft, but again, we know that this is an industry issue. And to solve it effectively, we need to, together, create build and packaging tools that output some sort of signed manifests, and have artifact ingestion tools, like CI tools, that apply policy and inventory and inspect artifacts. And then also even at runtime, so runtime on production systems, end user desktops, et cetera, some tools that validate to ensure that the artifacts that are running, again, apply policy and haven't been tampered with inside of the runtime environment. So what does this have to do with the CDF? Well, it seems like this is a great place for these types of conversations to happen. You know, we've got a lot of people who are producing these kinds of tools. Customers are interested in them. And so, you know, this seems like a place as, you know, CDF is still getting started, but as the processes come in place to create new working groups or to create special interest groups, this is certainly an area that Microsoft is interested in participating in. And if there are others of you that are as well, I welcome you to contact me, and we'll see if we can get something put together. That's all. Thank you.
Okay, it really is the year of Linux on the desktop. This is an abridged version of a talk I'm going to give tomorrow. I'm going to go pretty quickly, and hopefully it'll be interesting. I've got a bunch of live demos. So I'm going to talk about unit testing configuration using Open Policy Agent. I'm Gareth R. on the internet. I won't go into who I am too much, but I've just started a new job at Sneak, doing a bunch of product and security and building tools. Who's come across Open Policy Agent before? Scattering of hands, but not loads. It's one of the projects in the CNCF now. Ultimately, it's a component of a load of other tools. It's used as a generic policy enforcement engine. So it's quite handy me going last, because loads of other people were talking about where we need policy. Open Policy Agent is an implementation that can get us there quickly. It's used in a load of other tools. Gatekeeper is an admission controller for Kubernetes. And I'm going to show you another tool that I've been building using it. Ultimately, the short version is that Open Policy Agent, you bring policy described in a language called Rego. And you can bring data. For example, you might have a bunch of information of vulnerability data. And OPA is the engine that makes the decision. You put in your config or your response or your request or whatever it is, and it makes a decision. Obviously, then you can use that in lots of different contexts. The one that I'm probably most interested in is the development cycle. So if you like, whatever you're building, you might have some local development. That generally is you. It's you or maybe you in a pair. It's fast feedback. Your build test cycle wants to be fast. You're not running long-running tests. You're getting just enough work going. Continuous integration is great, combines things together from multiple different people, but you have to wait for the CI system. And deploying all the way to production probably takes a bit longer still. Like, all of these are good things, but they have different feedback cycles. Where Open Policy Agent has been used mainly within the Kubernetes community so far has been on that further away from the developer. It's been used in production clusters. It's been used to gate clusters from configurations that maybe wouldn't breach some organizational policy. That's great, but it doesn't have the immediacy of the feedback that I think you can have as well. So I've been asking, well, can we use Open Policy Agent as well, like on the left of our development cycle, like when we're in our continuous integration environments, when we're in local development? Several people earlier said everything as code. And no one shouted out heresy. I disagree massively. So I'm going to take it that everyone believes this is sort of a good direction of travel. But if we're writing code, should we be writing tests? I would say yes. Hopefully, other people agree with me there. So I want to introduce a new tool I've been playing with. It's open source on GitHub. I've showed a few people, but I don't think most people have seen it. It's called conftest. It tests configuration. Original naming is hard. So as an example of that from the Kubernetes space, like given a deployment, standard deployment, we can write our policy in this in Open Policy Agent's Rego language. So all we're saying here with this example is we should deny. We want to catch a bunch of things that we want to deny. We want to say, well, actually, if that input has a kind key, and that key has a value of deployment, and it doesn't have basically run as not root set to true, like let's say deny. What we're doing here is basically, with understanding of the Kubernetes deployment description, we're saying, hey, we're not running any root containers. That's a breach of our policy. That's our organizational policy. We don't do that. Let's go ahead. Obviously, it's a simple policy. You could make that more complicated. Maybe that's fine in some namespaces and not others. Maybe it's fine if you have you're in a whitelist. Your policies could be arbitrarily complex because Rego is a language for doing so. Conftest then just gives you a nice CLI tool to test your configs. Config test, point it at your config file, and, well, in this case, that one had a breach of policy. Let's see that in process. I'll try and juggle. Oh, actually. Oh. Let's see. So, could you just grab that? Oh, excellent. Thank you. Much appreciated. I've got a bunch of Kubernetes config files, but I won't look at those. Let's have a look at the policies because they're a bit more interesting. I have the deny one that I mentioned with some other bits and pieces here. We've got another common policy area might be, does this have the labels that we require for all of our containers? Slight change here as well. I've started building up a library of helpers for the Kubernetes space. But we've also got a few other things going on in there. We've got, actually, not just deny, we've got warnings. Maybe there are some things we want to say, you should know about this, but we haven't banned it quite yet. In this case, I'm warning if you're using services explicitly. Again, simple example, but you can do arbitrarily complex ones. One of the other interesting things about OPA generally is that it has an inbuilt testing mechanism. So actually, you can write tests for your Rego code in Rego. If you're thinking this has got meta and there are tests for the policies and I'm using a tool to test my configs, you would be correct. But I quite like that. Again, it's code. You should write tests for it all the way down. So actually, we can run our tests and we have some sense of, yeah, those policies have not got bugs in. So then we can conf test something, and we get a bunch of bits back. Thank you. I've got one more demo left. I will be very quick. So I'm going to go really quickly through this and not cover any of it. Come to my talk tomorrow. It's not just Kubernetes. It's any structured data we can test. So there's a bunch of serverless. There's a bunch of Terraform examples. There'll be as many examples as I can get in. I'll do one more demo because I told Christy I would do it. Obviously, adding this to a CI system is simple enough. And we've been looking at Tekton today. So I managed to get a Tekton example going. So we've got a task run spec here. It will grab a GitHub repository which has some Kubernetes configs in, and it will apply some policy from that repo. So I'll apply task run. So that's Tecton downloading images, downloading some code from Git, and then running conf test, which is packaged up as a container. Come on, why is it?
Will you be submitting this to our catalog?
Absolutely, that would be good. So make the text a bit bigger again. Oh, maybe not. And that's the output that's being run in the Tecton pipeline. Again, low-level example using conf test to test your Kubernetes configs while describing the build in Kubernetes configs. Even more meta. Thank you.